This is problem 2.9 of chapter 2, and we are adding forces to find the resultant force. In this case, we have three forces. F1, which is 60 pounds along this line, which is 45 degrees from the vertical line. We have F2, it goes 30 degrees from the vertical axis in the negative direction, it's in the third quadrant. And we have F3, which is along the y-axis in the negative direction. So we want to find the resultant force. And as you recall, the resultant force as a vector will be F1 as a vector plus F2 as a vector plus F3 as a vector. So the first thing that I'm going to do, I will use the components method, and I will decompose each of these forces. So let's do F1. F1 as a vector will have a y component and an x component. As you see, the x component is in the negative side of x, so it's a negative value. And it will be the value of the magnitude times sine of 45 in I. This is the x component, and we say that it's negative. And then we have the y component, which is 60 cosine of 45 in j. So F1 will be negative sine of 45. You know there is square root of 2 over 2, so that gives me 30 square root of 2 in I plus 30 square root of 2 in j. And this is in pounds. So we found the components of F1. Let's find the components of F2. F2, it says that it has a magnitude of 70, and it's the third quadrant. So we know, let me extend here my y-axis, so that the F2y will be negative, and Fx2 will be also negative. So F2x will be negative, and will be the magnitude, which is 70, we say that it's negative, times the opposite, right, which is sine of 30. Some people like to use this angle, which is the complementary angle, which is 60, and then use the cosine of 60. But remember, the cosine of 60 is the same as the sine of 30. So I will use the sine of 30, which is the opposite of this triangle. So it's sine of 30 in I. And then in the y component will be 70, also negative. Let me erase that positive sign. 70, and it's the adjacent of that triangle, which is cosine of 30 in j. So F2 is sine of 30 is 1/2, so this gives me 35 in I, and cosine of 30 is square root of 3 over 2, so that gives me 35 square root of 3. And this is in pounds. Well, this is also in pounds, and this is also in pounds. And finally, we have F3. And F3, this is a vector, so be careful with all the notation. So F3 is easy because it's only along the y-axis and it's negative, so it's minus 50 in j pounds. So now that we have all the components written in terms of components, we will add them, all the y components, all the I components, and all the j components. So we have our resultant force. I add all the I components, so it gives me negative 30 square root of 2, negative 35, and we don't have I components, so that's I. And in the y direction, I have 30 square root of 2, negative 35 square root of 3, and negative 50 in j. And I add all these components, right? So I add these terms and I add this term. Now I go with my calculator. Please notice that I always write a square root, because if I calculate the values from here, I will carry around an error. So square root of 2, at the end I calculate everything. So I really avoid carrying rounding errors till the very end. So at the end, I get that the resultant force as a vector will be equal to, so I add those two values together and I get negative 77.4 in I, negative 68.2 in J. This is my vector value, but I want the magnitude. And remember, the magnitude will be the square root of this square plus this square. So the magnitude, remember that the magnitude of the vector, I'm going to write it right here, will be fx squared plus fy squared. And then I have that the magnitude, if I square this value and I square this value, is 103.2 pounds. Now, to find the direction, I see that this is negative and this is negative. So my resultant force will be in the third quadrant, will be somewhere around here. So I am able to find this angle right here. So this angle right here will be the tangent of my Fy and F over Fx. So this is Fx and this is Fy. So Fry over Frx, which is tangent to this value over here, 68.2 divided by 77.4, right? And that gives me a value of 41.4 degrees. However, this is not the value that I want to report because I have to measure the angle respect to the positive axis. So I have to measure this angle right here. So what I'm going to do is add 180 plus that 41.4. And that gives me the correct value. Theta is equals to 221.4 degrees. So I was able to find the magnitude and the direction. So there is two ways to report the value as a vector with the two components, and this is a correct answer. Or with magnitude and direction, that is also a correct answer. So it's two ways. So this is a vector with two components, and this is a scalar, which only the magnitude and the direction.